Hello everyone, this is my presentation for our paper called Are Anonymity Seekers Just Like Everybody Else? An Analysis of Contributions to Wikipedia from Tor. First, let's talk about the background of the paper. So we find that user-generated content sites routinely block contributions from users of privacy-enhancing proxies like Tor. Their main concern is over the problem of vandalism, spam, and abuse caused by bad faith users without facing consequences. Among these sites, Wikipedia is a multilingual, web-based, free content encyclopedia project supported by the Wikimedia Foundation and based on a model of openly editable content by almost anyone. Almost anyone except proxy users are not allowed. If we were to edit an article on Wikipedia while using Tor, you would be greeted with this page saying you are currently unable to edit. In fact, Wikipedia has been banning Tor since as early as 2005 due to early concerns from some vocal members of the community, even though we have found no quantitative information about the frequency and the size of the vandalism problem. What is troubling is that for some people, contributing to public sites like Wikipedia would warrant the need for privacy-enhancing tools like Tor in order to avoid censorship and potential backlash from the portion of the community. The blanket ban has affected this population of users, but it has not been implemented perfectly, as we have found thousands of edits coming from Tor exit notes made it through from 2008 to 2018. This provides us with an opportunity to study and understand what is lost when anonymous users are not allowed to contribute to user-generated content sites like Wikipedia. With that being said, here are the main contributions of our paper. First, we have extracted and found 11,363 edits on Wikipedia, English Wikipedia by Tor users, along with thousands of edits on other languages. Second, we investigated and understood how Wikipedia implemented the banning method and what was the likely reason that the set edits were able to slip through the ban. Once we have obtained the dataset, we use both statistical analysis and machine learning tools to estimate the relative value of Tor users' contributions. In particular, we randomly picked samples of contributions belonging to various other suspects and compared their work with those made by our primary suspect, the Tor users, in order to see if there's a significant pattern that made Tor users distinctive from the crowd for them to receive such a heavy sentence. The other suspect includes non-logged in users whose work is credited to their IP addresses just like Tor users, and we refer to them as IP editors. Next, we have registered editors who made their first edit on their account, and we call them first-time editors. And finally, we have seasonal registered editors who have made more than one edit prior to the edit that we sampled. Now, let's back up a bit and talk about how we found and extracted the Tor edit dataset. As detailed in our paper, we had to use the combination of public record of the exit list, which records the operational hours of Tor exit nodes, and the consensus data, which records the consensus building process to form the Tor network. The consensus data is needed because often there are nodes who reach a consensus and become exit nodes hours before they are listed in the exit list. With the comprehensive list of Tor exit nodes, we then cross-checked with a list of Wikipedia edits to find edits that match the IP address at the same time as active as a Tor node. That is how we found the 11,300 edits on English Wikipedia, along with thousands of edits on other languages of Wikipedia. Please note that this dataset is dated as early as October 2008, as it is the furthest the Tor exit list can go back to. So this figure we are looking at here is the distribution of Tor edits over time. You can see here that due to the policy of blocking Tor nodes, the number of edits slipping through the block is very inconsistent. The spikes in the graph suggest that there were occasions when Wikipedia failed to ban the Tor exit nodes and Tor revisions were able to slip through. These larger spikes appear at least 5 times in the graph before the late 2013, when the edit trend finally died down and failed to rise back up again. To better understand why Tor users were able to edit Wikipedia at certain times but not others, we examined the history of Wikipedia's Tor blocking and banning mechanisms. We found that there are two ways Wikipedia's members prevent Tor users from editing. The first method involving banning by blacklisting individual Tor exit nodes, which is conducted by individual administrators and automated bots on Wikipedia. The second method involves temporarily blocking the IP address using Tor block extension from MediaWiki, the software that was installed on the servers that run Wikipedia. The main difference is that banning or blacklisting an IP address is set for a fixed amount of time, which means that even when that address stops being Tor node, it is still not able to make edits on Wikipedia, as long as the duration of the ban hasn't expired. On the other hand, the Tor block extension only prevents currently active Tor nodes from accessing the edit page, which does not have a long-lasting effect on those nodes. Upon searching the blog log and other sites discussing the policy against Tor users, we know that initially administrators rely on blacklisting the IP addresses. They installed Tor block extension in 2008, but it did not seem to work well initially and also went down occasionally. This is likely the reason how the edits were able to slip through occasionally until the extension was fixed by the end of 2013 and virtually managed to impede Tor users from editing. Now that we know how edits were able to slip through, let us examine the quality of Tor edits in comparison with the three aforementioned datasets. In order to assess the quality of contributions, we used several measures of quality that were developed within the Wikipedia community and by social computing researchers. Please note that because of the number of contributions to Wikipedia from Tor shrank drastically by the end of 2013, we divided and observed the edits in two separate periods from 2007 to 2013 and from 2013 to 2018. In the first period, we implement our analysis by identifying the trends over time, while in the second period, there are often not enough data points to make reliable observations each year. Therefore, we only replicate the prior analysis using the full dataset from 2014 to 2018. So the most widely used method for measuring edit quality in Wikipedia is whether an edit has been reverted. In Wikipedia, a contribution is said to be reverted if a subsequent edit returns a page to a state that is identical to a point in time prior to the edit in questions, and if the reverting edit is not reverted itself. So, in this diagram, the last edit is the reverting edit, and it effectively nullifies the changes made in edit 1 and edit 2 by returning to the original state in edit 0. We examined the reversion rate of each set of edits in our comparison groups, both overall and by year. We have to note that for this analysis, we only look at the reversion rate of edits made on main articles, as opposed to edits made on discussion pages and other special pages. We found that overall, Tor edits are significantly more likely to be reverted than other groups of edits. While this might seem like a bad news, we suspect that Tor edits are more likely to be reverted simply because they violate the Wikipedia's policy of blocking Tor. To assess whether or not this is the case, we examined the comments left by either users or bots on Wikipedia for reverting Tor edits and found some evidence suggesting this policy violations was a factor. We also looked at the instances of when Tor users try to revert other people's edits and found that they are significantly more likely to abuse this action. As you can see here, about 14% of Tor edits on article pages are revert actions, and most of them are actually reverted. This is a stark contrast against other groups of editors, especially IP editors and first-time editors, who are much less likely to revert other people. However, what this chart doesn't show, and is pointed out in our paper, is that when Tor users are not busy reverting someone else's work, their normal work is as good as first-time editors in terms of reversion rate, and only slightly lower than IP editors and registered editors. We conclude that the reversion rate may be underestimating the quality of Tor users' contributions. The next measurement of edits is called the persistent token revisions, or PTRs for short. The idea behind this measurement is that we want to determine whether at least parts of a contribution continue to be a part of the article over future revisions. meaning it is not altered by someone else for some time. We say for some time because articles often change over time, being updated with new information or by significant change in format. The value of contribution in short term is seen by the acceptance by subsequent editors who look and edit the articles, and it is both an indication of productivity, meaning how much work is actually added, rather than counting it as a single edit, and quality, meaning how much of work is kept. Following this intuition, PTR is the number of words or fragment of markups added to the articles in the collapsed edit and continue to persist over the next 7 revisions. For a detailed write-up about our calculation of PTRs, please refer to our paper. So looking at the box plot here, we can see that the contributions made by Tor users are largely similar to those made by IP editors and first-time editors. In fact, our main Whitney U test showed that Tor edits have significantly higher PTRs than both those groups, and only lower than the registered users. Of course, nothing measures quality as accurately as manual labeling, and our team has followed the guidelines laid out by Neuendorf to perform binary classification for each set. The output is whether or not an edit is damaging, and we perform power analysis and determine that 1000 edits for each dataset is needed to reliably determine the quality of edits. The result once again suggests that there are no significant differences between Tor edits and IP edits and first-time edits. Why they are still not comparable to register edits? As mentioned above, we performed the same computations for reversion rate and PTR count for the 4 subdataset dated from 2014 to 2018. Because it is now much harder to edit on Wikipedia tutor, we suspect a big difference in terms of quality of contributions by Tor users. The results actually surprised us. While it is true that Tor edits are much likely to be kept, as seen by the drastic reduction in reversion rate, other groups of edit also see a reduction in reversion rate as well, and Tor editors are seen to be comparable to first-time editors, while slightly worse than IP editors. However, in terms of PTR measurements, Tor editors perform significantly better than those two groups. While it is suspected that the improvement of Tor block extension leading to a higher bar of entry has made Tor edits significantly better, we also see a similar pattern of improvement among IP editors and first-time editors, suggesting that this bar of entry might not be the only factor of Tor edits improvement. Next up, we utilize different machine learning tools to classify edits made by the 4 groups. In contacting with members of the Wikimedia team, we were made aware of ORAS, a machine learning system used to assess the quality of edits and also spot possible vandalism attempts. ORAS uses many different features to determine whether an edit is of good faith, meaning it is not made with the intention of vandalizing the article, and whether or not it is non-damaging, meaning it doesn't make the article worse, whether by grammatical mistakes or bad format, etc. We use ORAS to run our 4 datasets, and the visualization shows that Tor, IP, and first-time editors are all compatible, with Tor editors appealing slightly higher quality contributions than first-time editors and IP editors, particularly in the later part of the data. These results provide additional evidence in support of our hypothesis that Tor editors, IP editors, and first-time editors are quite similar in their overall behavior, but that quality levels of contributions from registered editors are higher. Although average quality may be similar, Tor editors may differ systematically from other editors in terms of what they choose to edit. Knowing which topics Tor users edit might provide insights into their reasons in seeking anonymity and the value of their contributions. For example, Tor users might pay more attention to matters that are sensitive and controversial. Topic modeling may assist such an exploration by offering cluster of keywords that can be interpreted as semantic topics present in collection of documents. We use a tool called Machine Learning for Language Toolkit, or MALET, a tool that estimates the probability distribution of topics over the vocabulary of unique words. Using MALET, we can gain insights into the kinds of subjects that Tor users and other groups of editors pay attention to. After running our dataset numerous times on MALET, as detailed in our paper, we found that the results across the 5 most frequent topics for each group of edits are highly consistent, with the only slight changes in the keywords and the ranking. We also felt that having 20 different clusters of keywords for the whole text corpora led to the most reasonable and comprehensible topics and displays the results in the heat map here. The key takeaway is that, like other editors, Tor editors frequently edit topics such as movies and TVs and locations. We see proportionally fewer contributions from Tor editors in the sports, soccer, and American football topics. Compared with the other kinds of users, Tor editors are more likely to contribute to articles corresponding to politics, technology, and religion, topics that are considered controversial. We would like to conclude our presentation by going over the main takeaways of the paper. As shown in the previous analysis, Tor users are comparable to IP editors and first-time editors in many different ways. However, they also exhibit several important differences. We found that Tor users are significantly more likely than other users to revert someone else's work and appear more likely to violate Wikipedia's policy against back and forth editors, especially on discussion pages. Tor users also edit topics that are systematically different from other groups, as they are more likely to focus on sensitive topics such as religion, technology, and politics. With the Tor network steadily growing, we see this unrealized potential reward of creating a pathway for Tor contributors makes it the potential harm stemming from abuse. We are hopeful that our work can inform the community and encourage them to explore mechanisms by which Tor users can contribute to Wikipedia, perhaps with additional safeguards. For the acknowledgement, we would like to thank the following groups of people for their efforts and helpful comments to help us complete this research. I would like to thank the audience for listening to my talk, and now I would like to spend the remaining time to answer your questions, if any.